Chapter 1, Circuit Variables. In this lecture, we will recognize the importance of using SI units in circuit analysis, and we will review both SI units and some commonly used standard prefixes, and the circuit elements in which you will see them. SI is the abbreviation for the French phrase Système International, translated the International System of Units. We are looking at objective number 1, which is to understand and be able to use SI units and the standard prefixes for powers of 10. Let's look at some standard prefixes as they correspond to powers of 10 which are used in circuit analysis. Some small numbers and their prefixes are milli, which corresponds to 10 to the power of -3 and is represented by the symbol lowercase m. Micro, which is represented by the symbol mu and is 10 to the -6. Nano, which is 10 to the -9 and represented by the lowercase n. Pico, which is 10 to the -12 and represented by lowercase p. Some large numbers. Kilo, which is 10 to the 3rd and represented by lowercase k. Mega, which is 10 to the 6th and represented by uppercase m. Giga, which is 10 to the 9th and represented by uppercase G. And Tera, which is 10 to the 12th and represented by uppercase T. We will see milli and micro quite often when we are looking at inductors. So an inductor may be 3 millihenry, for instance. Capacitors tend to be very small. So we will see capacitors in the micro to nano or pico range. So a capacitor may be 120 picofarads, for instance. And the larger numbers we will see with resistors. So a resistor may have a value of 500 kiloohms, for instance. Or 1 megaohm. When converting these for use in equations, we will have to convert from millihenry to henry. So how do we do that? We would simply insert the value for milli in place of the m. So it'd be 3 times 10 to the -3 henry. And in this case, it would be 120 times 10 to the -12 farads. And the resistor value for 500 kiloohms would be 500 times 10 to the 3 ohms. And 1 mega would be 1 times 10 to the 6 ohm. Now you may be wondering, why did I not put this into scientific notation? For this class, I'm not going to ask you to do that. You will be using your calculator, and your calculator is perfectly capable of converting to scientific notation. I would recommend using engineering format. Okay, let's take a look at some standard SI units. They are based on 7 different quantities. For the quantity of length, we use the SI unit of meters, which is represented by the symbol lowercase m. For the quantity of mass, we use the SI unit of kilogram, which is represented by lowercase kg. Time is measured in seconds, which is represented by lowercase s. Now we are very familiar with pounds and hours, but these are not SI units. So when we are working with equations or circuit analysis, we have to convert time from hours into seconds or into SI units. Electric current is measured in amperes, which is represented by an uppercase A. It is an uppercase A because it is named after, it comes from a scientist, Ampere. So when units are named for a person, they are uppercase. Temperature is measured in degrees Kelvin, which is uppercase K and is equal to degrees Celsius plus 273. And an amount of a substance is measured in moles, which is lowercase mol. And our last quantity, luminous intensity, is the candela, which is a lowercase cd. For our class, we will be interested in current, possibly some equations with time, but we are more interested in some derived units. Some quantities that we use are derived by combining the defined standard quantities. You derived many of these formula in your circuits class, or excuse me, physics class. In circuits, we will use the following quantities and units. We will use the joule for energy of work. We will be using the power, watt for power, coulomb for electric charge, volt for electric potential, ohm for resistance, Siemens for electric conductance, farad for electric capacitance, and we will be using the Henry for inductance. And I already mentioned that we will be using the ampere for electric current. In this class, we will be working with quantities within the smaller range of milli, micro, nano, and pico, and quantities in the larger range of kilo, mega, giga, and tera. Let's do some example problems. If we are given 0.004 amperes and we want to convert it to milliamperes, so sorry about that. We know that there are 10 to the minus 3 amperes in 1 milliampere. So that would give us 4 milliampere. If we convert 0.00000075 farads to microfarads, we would take this value, and we know that in 1 microfarad we have 10 to the minus 6 farads. To convert to nanofarads, we would multiply 1 nanofarad there is 10 to the minus 9 farads. And in this last example, 0.0015 henries to microhenries. So 0.0015 Henry, and in 1 microhenry we have 10 to the minus 6 henries. So we would have 1,500 microhenry. Okay, in this lecture we reviewed standard prefixes and SI units that we will be using throughout the semester, and we solved some example conversion problems. This concludes our review of SI units and standard prefixes.